For the rest of the section, we are going to look at examples of functions that we learned in this section. Let's start with the example of power functions. In this example, we want to find the domains of power functions. The first one, f of x equals to 3 times x to the power of negative 2. So the coefficient here is the 3, and the exponent k is negative 2. To find the domain, it will be easier if we rewrite the function so that any root or denominator are visible. So I'm going to rewrite this function. F of x, which is 3 times x to the power of negative 2. Since the exponent is negative, so I can rewrite that as a reciprocal. So this also equals 3 divided by x squared. The variable x is in the denominator, and we can never have a zero denominator. So now we have a constraint on the x. Denominator cannot be 0, which means x cannot be 0, or x squared cannot be 0. So, if we use interval notation, domain would be from negative infinity to 0 exclusive union 0 to infinity. How about part B? G of x equals to half times x to the power of 3 over 4. Again, I want to rewrite the function so that any roots or denominator are visible. Here the exponent is 3 over 4. So I can rewrite this function as the coefficient half times the fourth root of x, then whole thing, cubed. Here I have a fourth root. So what's inside the root has to be positive, which means x has to be greater than or equals to 0. Then using the interval notation again, the domain of g of x is from 0 inclusive to infinity. The next function, h of x. h of x equals to 2 times x to the power of negative 4 over 5. Again, let's rewrite the function so that any root or denominator are visible. The coefficient remains the same, 2, and the exponent is negative, so I can write that in the denominator. 1 over, then the exponent would be 4 over 5, which means it is a fifth root of x, and this to the power of 4. Since the fifth root is an odd root, so what's inside an odd root could be positive or negative. So x could be either positive or negative. However, the variable is still in the denominator. So there's another constraint on x, which is the denominator cannot be 0, which means x cannot be 0. So using the interval notation, domain of h of x is from negative infinity to 0 exclusive, then union 0 to infinity. And the last function, k of x. K of x equals to 8 times x to the power of negative half. Let's rewrite this so that roots and the denominator are visible. The coefficient remains the same, 8. The exponent of x is negative half. We have the negative sign, so we can write that in the denominator. 1 over x to the power of half. And the exponent of half also means the square root. So we have 1 over square root of x. There are two constraints. First of all, x is inside the square root, and what's inside the square root has to be positive. So x has to be greater than or equals to 0, and the denominator cannot be 0. So x cannot be 0. Then if we combine these two, that means x has to be greater than 0. So using the interval notation, domain of k of x is from 0 exclusive to infinity. And that is the end of the lecture. In the next lecture, let's look at an example of polynomial function.